Notebook, done by CP1401. Remember is inclusive of Ang Cheng Chun 144544A, Karen Lim Li Ling 143336R, Sabrina 143024U, Nurul Azlina 145901A, and lastly Vagisa 141256F. The chosen topic will be topic 1, which is integration by parts, where differentiation of uv equals to differentiation of u plus differentiation of v. So by integrating both sides, we get uv equals to integration of u d over dx dx plus integration of v d over dx dx equals to integration of u dv plus integration of v du, whereby integration of u dv equals to uv minus integration of v du. For the priority order for the choice of u, we follow LIATE, where L stands for logarithm, example log 2x, I stands for inverse trigonometric, example inverse sine x, A stands for algebra, for example x, or a constant like 1, T stands for trigonometric, example sine x, E stands for exponential, example e to the power of x. Using method 1, find integration of x times square root x plus 1, where x and square root x plus 1 is in the group of A, which is algebra. U equals to x and du equals to dx, whereby dv equals to x plus 1 to the power of half, and v equals to integration of dv, which means integration of x plus 1 to the power of half, equals to x plus 1 to the power of 3 over 2 divided by 3 over 2, and which is equals to 2 over 3 times x plus 1 to the power of 3 over 2. Using integration by parts, we know that integration of u dv is equals to u times v minus integration of v times du. So integration of x times square root x plus 1 is equals to x times 2 over 3 times x plus 1 to the power of 3 over 2 minus integration of 2 over 3 times x plus 1 to the power of 3 over 2, which is equals to 2x over 3 times x plus 1 to the power of 3 over 2 minus 4 over 15 times x plus 1 to the power of 5 over 2 plus c. Method 2 will be in tabular form, where you draw a table to separate differentiation and integration, where you differentiate u until is equals to 0 and you integrate v until it reaches the same row where u is equals to 0. U has an alternative positive and negative, and as you can see in the arrows, that is how you multiply them together. Therefore, integration of u dv is equals to positive u times v1 minus u prime times v2 plus u double prime times v3 and so on, and lastly u plus c. So now we are comparing method 1 and method 2 using the example of integration x squared times sin x. Using LIATE, we know that x squared is equals to a and sin x is in the group of t. So using method 1, u is equals to x squared and du equals to 2x dx, whereby dv equals to sin x dx and v equals to negative cosine x. Therefore, integration of x squared sin x dx is equals to negative x squared times cosine x minus integration of negative cosine x times 2x dx equals to negative x squared times cosine x plus 2 times integration of x cosine x dx, and to evaluate integration of x squared cosine x dx, use integration by parts a second time. Whereby this time u is equals to x, du equals to dx, and dv equals to cosine x dx, and v equals to sin x. Therefore, integration of negative x squared cosine x plus 2 times integration of x cosine x dx is equals to negative x squared times cosine x plus 2 times x times sin x minus integration of sin x dx equals to negative x squared cosine x plus 2 times x times sin x plus cosine x, and lastly plus c. Using the same example, but using method 2 in tabular form, you let u equals to x squared and v equals to sine x, where you differentiate x squared until it's equals to 0, where u has the alternative of positive and negative, and you integrate sine x until it reaches the same rule as u equals to 0, and you will get cosine x. Therefore, integration of x squared times sine x dx is equals to negative x squared times cosine x plus 2x times sine x plus 2 times cosine x plus c. There is method 3, which is differentiate method, and conditions to use method 3 would be when ex times sine ax, or ex times cosine ax, or sine ax times sine bx, or sine ax times cosine bx, or cosine ax times cosine bx. Using this method, where integration of fg is equals to f times g prime minus f prime times g over m minus n plus c, where f double prime equals to mf and g double prime equals to mg. M cannot be equals to n, and c is the constant of integration. So using an example, find integration of e to the power of ax times cosine bx. You let f equals to e to the power of ax and g equals to cosine bx. And you differentiate both of them twice. And when comparing f double prime and f, you will get n equals to a squared. And comparing g double prime and g, you will get m equals to negative b squared. And since m minus n is equals to negative b squared minus a squared, which is not equals to 0, it follows the condition of method 3. Using the previous formula, integration of e to the power of ax times cosine bx is equals to e to the power of ax times negative b sine bx minus a times e to the power of ax times cosine bx divided by negative b squared minus a squared plus c. And to simplify it, is equals to e to the power of ax times bx plus a times cosine bx divided by a squared plus b squared plus c. In summary, use method 1 and 2 when u equals to a and has the power of 1. Use method 2 when u equals to a and has the power of more than 1. Use method 1 when u equals to L or I. And use method 3 when u equals to E or T. Our roles: Ang Cheng Chun, editor 2 and cameraman; Karen Lim Lui Ling, story writer; Sabrina, voice actress; Azlina, hand actress; and lastly Valisa, director and editor 1. The end.